How slow is JDBC for databases? Let's test it practically, using Oracle as an example for an intuitive understanding. Generate 10 GB TPCH data and use the customer table for testing. All tests are implemented on the local server without consuming network transmission time. Retrieving the customer table through JDBC interface provided by Oracle takes 275 seconds. Reading the local file, customer TBL, through Java's I/O stream takes 43 seconds. This means that reading text is many times faster than reading Oracle. We know that text parsing can be quite complicated. However, reading data from text files is still generally much faster than retrieving it from databases. When executing this simple SPL statement in the database, there are no other database operations, so it can be ruled out that the slow data retrieval of JDBC is caused by the heavy burden on the database, but rather by the JDBC itself. JDBC drivers are typically provided by database vendors, and there is little opportunity for external parties to enhance the efficiency of JDBC in data retrieval. When the database load is light, we can implement a multi-CPU parallel solution to enhance the efficiency of JDBC data retrieval. However, writing parallel programs in Java can be quite challenging due to issues like resource sharing conflicts. The parallel technology of SPL can enhance the performance of JDBC data retrieval by alleviating the complexity of hard coding in Java and facilitating the merging of multi-threaded result sets. In the IDE, you can create a new JDBC connection from the Connect to Data Source menu. Fill in configuration information. In practical applications, it is usually necessary to manually fill in JDBC configuration information in Raxofconfig XML. The total time required for parallel data retrieval tasks is determined by the slowest thread. To retrieve all the data faster, it is necessary to divide the source data into multiple relatively average segments. For example, in the line item table of TPCH, the order key is divided into 4 groups by modulo 4, and the number of records in each group is counted. The sequel is like this. Observing the execution results, it can be seen that the number of records in each group is approximately equal, and then 4 data retrieval threads can be used to correspond to these 4 data sets, with each thread's retrieval time being quite similar. Taking the line item of TPCH as an example, the script for parallel data retrieval with 4 threads looks like this. Among them, n is the script parameter. For the use of parameters, please refer to relevant tutorials. Setting the value of n to 4 will generate 4 threads in A3, each executing code blocks B3 to B7 simultaneously. It should be noted that each thread needs to connect to the database separately in order to truly achieve JDBC parallel data retrieval. The SPL actually executed in B5 is like this. Let's take another example. In the customer table, cusKey is a natural number starting from 1. Therefore, the total number of records can be calculated in A2 first. Divide it evenly into n segments in A4, where n is 4. Finally, A5 performs parallel computing, with each thread connecting to the database and executing SPL using the cusKey interval as a parameter. In practice, it may be necessary to adopt other methods to set SPL segmentation conditions to achieve relatively average segments, such as dividing dates by quarter and types by category. The key is to ensure that the number of records in each segment remains similar after segmentation. When using non-parallel data retrieval for multiple different tables in a database, only each SPL statement would be executed sequentially, resulting in suboptimal performance. Although multi-table parallelism cannot guarantee even data distribution, parallel computing can effectively improve data retrieval performance. It should also be noted that in parallel code blocks, B7 connects to the database separately in each thread. SPL encapsulates the standard JDBC interface, allowing it to be called by importing the SPL driver and using the SPL script. This process aligns with standard database JDBC calls to stored procedures, so we will not elaborate further. When retrieving data in parallel from multiple tables, multiple result sets will be returned, and each result set needs to be looped through in Java. The capabilities of SPL extend well beyond this. It can also be utilized for text calculations, SQL migration, support for mixed databases, and various non-database computations. Additionally, SPL's computing power can be leveraged for school performance optimization. We will gradually introduce these topics in the upcoming practice series. SPL is open source software available for download on GitHub.